The next type of pattern that we saw was one that grew by multiplication or division. These are known as geometric sequences. They actually model exponential relationships. We haven't fully learned about these type of functions yet. We are going to start learning about them more tomorrow, but these just do not represent lines or quadratic functions. They represent exponential relationships. So we saw in the beginning that this other pattern was growing by times 3 each time. So this is what we would call the common ratio. Geometric sequences do not have common differences. They're not growing by addition or subtraction. They have common ratios. This is because they grow by multiplication and division. We cannot technically call this term slope because it is not modeling a linear relationship. So there are two types of formulas for a geometric sequence as well. There's the recursive one, which is a sub n equals a sub n minus 1 times r. It's very similar to the arithmetic one, where the n's are just representing any position number whatsoever. But this time, instead of having a d in the formula, we have an r because we have a common ratio. So that's just whatever we're multiplying or dividing by. Same thing in the explicit formula. The n's represent the term number. A sub 1, just like last time, represents the first number in the sequence, and r represents the common ratio or the pattern. So, if we were to use this sequence, 1, 3, 9, 27, and they asked us to write either one of these formulas for this particular sequence, using the recursive one, it would be a sub n equals a sub n minus 1 times the common difference here, common ratio, is times 3, so there would be a times 3 there. For the explicit formula, it would be a sub n equals a sub 1 is 1, the first number here was 1, times the common ratio was 3 to the n minus 1 power. So we could use either one of them, but if we use the recursive one, if I wanted to know the 50th number, I would have to know numbers 1 through 49 to build on it to find the 50th number. In the explicit one, as long as I just knew the first term and the common ratio, I could jump straight to the 50th term. So we're going to focus more on using the explicit one. I just wanted you to see and be familiar with both of them. So if we want to write the explicit formula to find any number in this sequence, we have just written it. So we know that a sub n is equal to 1 times 3 to the n minus 1 power. Now if they wanted us to find the 30th term in the sequence, they would write it as a sub 30. That's telling you to find the 30th term. We would have a sub 30 is equal to 1 times 3 to the 30 minus 1 power. So I need to know what 1 times 3 to the 29th power is. So really, even though I'm going to do 1 times last, I really just need to know what 3 to the 29th power is, because I need to follow order of operations. So 3 to the 29th power is an insanely large number. 68, 630, 377, 364, 883. So we would have that number times 1, which is just that number. So this is the 30th term in this particular sequence. So I'm definitely not going to sit there and times 3 every time. This is why having a formula is useful. So write the explicit formula to find any number in the sequence and then find the next 3 terms. Okay, so this one looks a little bit more complicated. I've got some fractions going on. In the beginning, it's not so fuzzy. I can see to get from negative 96 to 12, it probably wasn't subtraction. This is going kind of funny. I told you that if I think it is growing by multiplication or division, I can work backwards and use division to find the common term, the common ratio, So if I took 3/16 and I technically divided it by negative 3/2, if I remember how to divide a fraction by a fraction, I keep the first term, change it to multiplication, and flip the second term. So really this is negative 3 times 2 is negative 6 over 3 times 16 is 48, or I could have cross-reduced inside. Either way, this is giving me the common ratio, but I need to simplify it to find out that my common ratio is -1/8. So even if I continue to go backwards, every time my common ratio is -1/8. Now that does mean the same thing as dividing by a -8, but when we write the common ratio, it is the number that we are multiplying by. So if you see that your pattern is dividing by 4, your common ratio is really 1/4 because that is the number you are multiplying by. So if we're writing the explicit formula, just to remind ourselves what that is, a sub n equals a sub 1 times r to the n minus 1 power. So it would be a sub n equals, a sub 1 here is -96, r we just found is -1/8 to the n minus 1 power. That would be the formula to find any term in this pattern. And it says find the next 3 terms. Okay, so I could continue this just by dividing by -8 every time, or I could actually plug it into the formula. It's not usually this complicated, it just seems that way because these are fractions and I'm doing more fractions and we hate fractions. So if I continued this and I tried to find if this is the first, second, third, and fourth number, and they want us to find the next 3 terms, we're trying to find out a sub 5, a sub 6, and a sub 7. So if I was trying to find a sub 5, it would be -96 times -1/8 to the 5 minus 1 power. So that would have to be -1/8 to the 4th power first. So if I did -1/8 to the 4th power, that would be a decimal, a pretty long one, 0.0002441406, and then I multiply that by -96, and that leaves me with -0.02344375. Now later we're going to start applying this to actual applications, and we would not be writing the entire number out. We'd probably be rounding to 2 or 3 decimal places, but that is technically the entire answer as a decimal to the 5th term. So you would do the same thing to find the 6th and the 7th. I gave you a really hard problem. It wouldn't be this bad. We're probably going to use really clean numbers, but that's how you would do it. So the first term of a geometric sequence is 6, and the common ratio is -2. What is the 10th term of the sequence? So this is a geometric sequence. We're going to use the explicit formula. So a sub n equals a sub 1 times r to the n minus 1. They tell us the first number and they tell us the common ratio. So to fill in the formula, a sub n equals 6 times -2 to the n minus 1 power. They want to know the 10th term. So we're going to do a sub 10 equals 6 times -2 to the 10 minus 1 power. This one's a lot cleaner. So 6 times -2 to the 9th power. So 6 times, find out what -2 to the 9th power is, and that happens to be -512, and then I would multiply that by 6 to get our answer of a sub 10 equals -3072. So that is the 10th term in this sequence. Given the explicit formula for a geometric sequence, find the 8th term in the sequence. So they already wrote the formula for us. We're just trying to find the 8th term. So wherever we have an n, or the term number, we're going to plug in an 8. So a sub 8 is equal to 2 times 1/4 to the 8 minus 1 power. So 2 times 1/4 to the 7th power. So we could, if they made us give it as a fraction, sit here and do 1/4 times 1/4 times 1/4 and continue to do that till I get to the 7th power, but they didn't specify, so we can do it as a decimal. So that is 0.25 to the 7th power. And that gives me a really long decimal, bunch of zeros in front of it. And then I'm going to multiply that by 2. And so the actual answer for the 8th term in the sequence is 0.0001220703. That's in decimal form. If you wanted it by a fraction, there is a way in the calculator to switch back and forth between decimals and fractions. I will have to show you that in class, but that is technically our answer. So our final example is an application example. It says a bungee jumper jumps from a bridge. The diagram to the right shows the bungee jumper's height above the ground at the top of each bounce. So the first bounce, he goes up 200 feet, then 80 feet, then 32 feet. So as this is happening, it's actually forming a geometric sequence. It says, what is the bungee jumper's height at the top of the 5th bounce? So I see I'm going from a larger number to a smaller number, so I'm probably technically dividing, but I need to find out the fraction that we're multiplying by. So we could go backwards, and we could use the last term and divide by the previous term to find out what our geometric common ratio is. So 32 over 80, I would need to reduce that. 80 over 200, I would need to reduce that. So for both 32 and 80, 8 goes into it, and it can go even further. If I just reduced by 8, I'd have to keep reducing. So there is a number that goes into both of them that is even larger, and that number is 16. So 32 divided by 16 will give me 2 on top, and 80 divided by 16 will give me 5 on bottom. So far I think my common ratio is 2/5. If I do it again, and I do 80 over 200 and I reduce that, clearly I can cancel out some zeros here, and I'm really looking at 80 over 20. And so 4 will go into 8 twice, and 4 will go into 20 5 times. So again, I have confirmed my common ratio is 2/5. So if I know R is 2/5, and I know the first height, or the first term in the sequence, is 200, and they want me to find the height of the 5th bounce, I'm going to use the explicit formula, a sub n equals a sub 1 times r to the n minus 1 power, plug in what I know. A sub n is equal to 200 times 2/5 to the n minus 1 power. And if I want to find the 5th bounce, I've got a sub 5 equals 200 times 2/5 to the 5 minus 1 power, which is really the 4th power. So if I do 2/5 to the 4th power, that gives me 0.0256. And then if I multiply that by 200, the answer is 5.12. So if these are in feet, after his 5th bounce, it'll keep going shorter and shorter away from the ground. He will be 5.12 feet. That would be the answer to the 5th bounce.